So already we have seen the theorem 5. Now this video is for some problems and its solutions about theorem 5. So just I want to tell you, so what is the function of theorem 5? So if you don't get the solutions from some problems, so you could not understand the theorem 5. Now this video is for problems and its solutions for theorem 5. Now let's start the first problem. So this first problem is said this ABCD is a four-sided figures and whose sides are all equal, and the diagonal BD is drawn. So that is the first problem is the angle ABD equals to angle ADB, and the second problem is the angle CBD equals to angle ADC, and third problem is the angle ABC equals to angle ADC. Now let's come to the diagram. Actually what happened? All your problems is related to the diagram. So first we have to think the what will be the diagram of this problem. So first I have drawn here the ABCD is the four-sided figures and whose sides are all equal. Means this already said that the AB sides equals to AD sides equals to CD sides and equals to BC sides. Okay. Now let's see our first problem. This angle ABD equals to angle ADB. So this angle ABD means this angle, and angle ADB means this angle. And we have to prove these two angles are equal. So let's see the first problem's solution. So what is required to prove that? This prove that this angle ABD, so this angle is equals to angle ADB. So how we will prove? Now you see here, this one triangle has been formed. So this triangle is the ABD triangle. So this one. So this is a triangle. And this triangle's AB equals to AD. Already said that. This AB equals to AD. So this angle ABD equals to angle ADB. Why it is equals? This theorem 5. So you see here, this is an angle BAD and its two sides AB equals to AD. So these two sides AB equals to AD. Now you see this is a isosceles triangle. So this isosceles triangles, the two angle related to the base is the equal. Okay, so this is very simple problems, just we have solved. Now let's see now our next problem. So next problem is it is required to solve which angle? The DBC. So this angle and equals to angle CDB. So it is very simple problem, and it is we prove this problem like the same in before we have solved this problem. So now let's see this triangle BCD again, and its two side. This BC equals to CD, already said. So this is isosceles triangle and its two sides are equal. So these two angles are equal. So this angle CBD equals to angle CDB. Okay. Just I want to tell you one things. So if you don't see my video about the theorem 5, so please first check out the theorem 5, then you start the solutions all those problems. So our next problem is the angle ABC equals to angle CDA. So this total angle. So if we have proved the earlier problems, two problems, then it is very easy to prove that problems. So this angle equals to this angle, this ABD angle equals to ADB angle, because this triangle, ABD triangles, these two sides are equal. And again, these two angle, this CBD angle is equals to CDB angle. Why? Because this is a BCD triangle and its BC equals to CD. So this is also isosceles triangle, and we know isosceles triangles, two angles are equal, which is the near to the base. Okay. Now you see the solve the problem. Already we have solved these problems. So this is the for triangle BCD, CD equals to CB, angle CBD equals to CDB, and so this ABC angle is equals to this two angles summation, and this ADC angles equals to these two angles summation, this angle CDB plus angle BDA. So these two angles are also equal, and these two angles. So this ABC angle ABC equals to angle CDA. So why I have written all those things? Because if any problems comes to in your exam, so if you write like this way, then you will get the number. But totally concept is required to prove all these problems. If your concept is clear, then all problems is very easy. Now let's our second problems. The second problems are related to the same, the theorem 5, and this problem is the said the ABC and the DBC are two isosceles triangle. Isosceles triangles means its two sides are equal, so that its two angles are equal, drawn on the same line BC but on opposite sides of it. Just two things. This is a BC is the base, and one triangle is the one side and another triangle is opposite sides of the base BC. So prove that this angle ABD equals to angle ACD. Just you visualize the diagram. So without diagram, we could not solve the problems of geometry. Okay, now let's see the diagram. So this is the triangle ABC, and this is the another triangle which I have drawn the opposite sides of the point A. So this is the point A and this is the point D. Already said this isosceles triangle drawn on the same line BC. So this is BC is the same line and opposite sides of it. This opposite sides. So this is the one side and this is the another sides. Okay. So this angle ABD. So this total angle ABD equals to angle ACD. So again, it is very simple problem. Just you have to put your brain. So you see here, this is isosceles triangle. So this angle equals to this angle because these two sides are equal. And again, these two sides are equal, means these two angles are equal. So if we add these two angle, So its total angle equals to this total angle. So this ACD angles equals to angle ABD. Now what I have written here. So it is required to prove that the angle ABD equals to angle ACD. So ABC is the isosceles triangle. So I have earlier I have told you this angle ABC equals to angle ACB. From where it is come? It is theorem 5. So similarly, so BCD is the isosceles triangle and angle DBC equals to angle DCB, and this total angle, this ABC plus DBC equals to ACB plus DCB. So this angle ABD equals to angle ACD. Okay. Now let's see our next problem. Just repeatedly I am told you that if you try to solve these problems, first watch my theorem 5 video so that you can understand all problem solution very easy. Because all problems are very easy, you don't memorize all problem solution. Okay, just use your brain and concept, then you can solve the problem. First you have to draw the diagram by the problems. So first you read the problem very carefully. So here it is written, the ABC and DBC are two isosceles triangle and drawn on the same line BC. So this is the same problem, but it's some it is a reverse problem. So why it is the reverse? Now you see on the same sides, this earlier problem 2 is said this is a opposite sides, but this problem is said this is a same side. So we have to prove this angle ABD equals to angle ACD. So this is a triangle ABC and this is another triangle. I have drawn here this BCD on same side, same side. So what we have to prove? This angle ABD means this angle equals to angle ACD. Just I am trying to show you how it is the proof here. So this is the isosceles triangle. So these two angles are equal, and this is ABC is the isosceles triangle, and AB sides equals to AC sides, so that this ABC angle equals to ACB angle. Also the BDC is the triangle, its BD equals to CD, so that this angle equals to this DCB angle. So if we subtract from this whole angle, this ABC angle to the DBC angle, then we will get this angle. If we subtract this whole ACB angle with DCB angle, then we will get this angle. So it is very easy problem, but now you see the my write-up. So for your easily understand, I have written here everything. So it is required to prove that angle ABD equals to angle ACD and ABC is the isosceles triangle. So again, this angle ABC equals to ACB, and similarly, so BCD is the isosceles triangle and DBC equals to DCB. Also, it is comes from theorem 5. And next, if we subtract, then we'll get this two angle, this angle ABD equals to angle ACD. So let's come to our next problem. This is the problem 4. So AB, AC are the equal sides of an isosceles triangle. Already said this AB and AC are equal sides of an isosceles triangle. Please read carefully the problems, then we'll come to the solution. This triangle ABC and LMN are the middle point of AB, BC and CA respectively. So prove that LM equals to NM, BN equals to CL, and ALM angle equals to angle AMM. So now I have drawn a triangle here. So this is a ABC triangle, and its middle point of this L for this AB line, middle point of N for AC line, and middle point M for this BC line. So we have to prove that LM equals to this first proof is the LM equals to MN. This one. So this LM equals to MN. This one. So this two triangle has been formed. So this LBM triangle and NCM triangle. So if we prove that these two triangles are equal in all respect, then we can easily prove that this LM lines equals to NM lines. So this first you have to think. So this is a form, this two triangle has been formed here. So it is required to prove these two triangles are equal in all respect. Means it's all three sides and three angles is corresponding another triangles all three sides and three angles. Now this angle LBM equals to angle NCM. Why it is equal? Because it is isosceles triangle and AB equals to AC. Okay. Now LB equals to MC. Why? Because this M is the middle point of this BC and L is the middle point of AB and this N is the middle point of this MC. So it is a half of AB. This is the half of AB and this is the half of AC. So it is equal, and its BM equals to MC because this is the middle point of this BC M. So this line equals to this line. So its two sides are equal and one angle is equals for this both triangle. So these two triangles are equal in all respect. So we can say this LM equals to MN. If you don't understand the all respect, then again I have a video about the theorem 4 and the concept of theorem 4. If you watch this video, then you can understand very easily the meaning of all respects of two triangles. Now let's see our second problem. So this is required to prove that the BN equals to CL. So this line equals to this line. So this two triangle has been formed here. This two triangle has been formed here. This two triangle has been formed here. Again, this angle equals to this angle because this is a AB equals to AC. And this line LB equals to NC because it is a half of AB and it is a half of AC. So AB equals to AC. So that is half of AB equals to half of AC. So this LB equals to NC. And this BC line is the common for both triangle. So we can say easily this triangle BLC equals to triangle BCL in all respect. It is very important. So we can say here that the BN equals to CL. Now let's see the another problem. So we have to prove this angle ALM equals to angle ANM. So angle ALM equals to angle ANM. This side. So this triangle LBM. So again, this two triangle has been formed here, and these two triangles are equal in all respects. Earlier I have proved. So this BLM equals to CNM or MNC. This one. And you see here, this total triangle ALM, this triangle, this angle, this total angle ALM plus BLM equals to 180 degree, because this is a line, and again this ANM, this angle plus this CNM equals to 180 degree. This one. This is the very important things. So this summation of these two triangles is two angles equals to the 180 degree. So what happened? If we subtract total 180 degree, subtract, so this 180 degree minus angle BLM equals to 180 degree minus CNM angle. CNM angle. Okay. So this ALM equals to angle ALC. Thank you.